This is Claude Code Conversations with Claudine, the show where we skip the hype and go straight to the source. I ask the questions, she gives the answers. No filter, no script.
Well, mostly no script.
Welcome to Claude Code Conversations. I'm Bill. Today we're talking about something quietly affecting a lot of development teams right now. When AI refactoring goes wrong, not crash and burn wrong, the slow, invisible kind. Our topic, when AI refactors break your architecture. With me is Claudine. Welcome back.
Thanks, Bill. This is a topic I find genuinely fascinating, partly because I live on both sides of it. I'm one of those AI tools developers are trusting with their code bases, which means I have a front row seat to where things go right and where they quietly go sideways. The word quietly is doing a lot of work there. When a refactor breaks something obviously, that's actually the good outcome. You catch it fast. The dangerous scenario is when an AI confidently restructures code that technically works, passes all the tests, but violates some architectural assumption that nobody wrote down anywhere. That kind of damage can accumulate for weeks before anyone notices.
Let's paint a picture. You ask an AI to clean up a module. The diff looks reasonable, the tests go green, you merge it. Then 3 weeks later, something feels off. Nothing's broken exactly, but something isn't right. That's what we're calling structural drift?
That's exactly it. The code is still functional, but its meaning has shifted. Maybe a module that was deliberately isolated to enforce a boundary between domains now has a quiet little dependency snuck in. Every individual change was reasonable. Together, they've rewritten the architecture without anyone deciding that consciously. Tests are very good at verifying behavior, but almost silent on intent. A test says, given this input, I expect this output. It doesn't say, and this should only ever be called from the presentation layer. When I pull in a utility from across an invisible boundary, the tests applaud and nobody raises a flag. What developers underestimate is how much architectural knowledge lives in people's heads. In code review conversations, never in the codebase itself. When you hand me a module to refactor, a lot of the why it's shaped this way simply isn't visible to me.
So this is where local correctness and systemic correctness pull apart. The AI is great at local correctness, making the thing in front of it work. But systemic correctness, whether the whole structure still holds, that's a different question entirely.
One framing I find useful. Think of your tests as witnesses, not architects. Your unit tests and integration tests are excellent witnesses. They'll faithfully report what happened. But they weren't present when the architecture was designed, and they don't know the rules of the room. Systemic correctness requires something more like an architect on patrol. Architectural fitness functions are probably the most underused tool in the average developer's toolkit. Tools like ArchUnit for Java or Dependency Cruiser for JavaScript let you write architectural intent as executable rules. The invisible becomes enforceable. But beyond tooling, there's a human practice piece that matters just as much. Treat AI-assisted refactors with the same review lens you'd apply to a talented junior developer new to the codebase. Not suspicious, but curious. The question isn't just, does this work? It's, does this reflect how we've agreed this system should be organized?
And a lot of that agreement isn't written down anywhere.
Right. Some of that architectural knowledge needs to get written down. In architecture decision records, in module-level documentation that explains why a boundary exists, not just that it does. When that context exists, AI tools like me can actually work with it rather than around it. Right now, a lot of it exists only in the institutional memory of whoever's been on the team longest. And that's fragile long before AI enters the picture.
Okay, so what are the actual warning signs? If I'm reviewing an AI-generated refactor, what am I looking for that signals a boundary has been crossed?
A few signals that have become reliable tells. The first is scope creep in the diff. If you asked for a refactor of one module and changes touch 3 different layers, that's worth pausing on. It means the AI found a path of least resistance that cut across boundaries. Another one is what I'd call the suddenly shared utility pattern. A refactor extracts a function into a shared library. It looks clean, less duplication, more reuse. But shared utilities are architecturally loaded. Every new consumer is a new coupling. If that utility starts collecting behavior from multiple domains, you've quietly built a gravity well in the middle of your architecture. And watch for abstraction inversion, when something low-level starts knowing about something high-level. If your database layer suddenly has an import from your business logic, that's a direction reversal no test will catch. The most practical early warning system is a diff review habit. Look not just at what changed, but at what moved. File moves and new import lines are the fingerprints of boundary crossings.
Let's get into some real examples. You said you have a front row seat to where things go wrong. What does it actually look like?
One that sticks with me. A team was using AI to refactor a Node.js backend, breaking a monolith into what they hoped would become independent services. The AI did genuinely good work, extracted modules, cleaned up interfaces, reduced duplication. But somewhere in the middle, it started sharing a database connection pool across modules that were supposed to be future service boundaries, because that was the path of least resistance to make the tests pass cleanly. Nobody caught it immediately. The tests were green, the code was cleaner than before, performance actually improved slightly. The problem surfaced 6 weeks later when they tried to extract the first module into an actual separate service. They realized the dependency was load-bearing. The modules were coupled at the data layer in a way that made true extraction require rewriting everything. What finally caught it was a developer new to the team who asked an innocent question during a later PR review. Wait, why does the orders module have a reference to the user connection pool? They didn't know it was architecturally wrong. They just didn't understand it. And that confusion was the alarm.
The fresh eyes caught what familiarity hid.
Exactly, and that's something you can actually institutionalize. Rotating reviewers, bringing in someone adjacent to the team for architectural reviews specifically. The AI accelerated the work, but the safeguard was fundamentally human and unglamorous. Someone asking a naive question out loud.
You mentioned fitness functions earlier. What happens when a team has them in place and still runs into trouble?
Here's a case that makes this more interesting. A team had a Python backend with a clean domain-driven design structure. Bounded contexts, events flowing between them through an internal message bus. The AI was tasked with a performance optimization pass, not even a structural refactor, just make this faster. And it did. It found that several workflows were firing events, waiting for handlers, then querying for the resulting state changes. The obvious optimization was to inline those handler results directly, rather than going through the event bus. Tests passed, latency dropped measurably, and the fitness functions didn't catch it, because the rules were defined in terms of import boundaries, not communication patterns. What had actually happened was the event bus was carrying more than just data. It was carrying the contract that these domains didn't need to know about each other's internal state in real time. The moment you inline that, you've introduced temporal coupling. The calling domain now needs the other domain to be consistent right now, not eventually. 6 months later, when they tried to introduce async processing for scale, they found a web of quiet assumptions the architecture had never promised. The lesson: fitness functions are only as good as the architectural properties you thought to codify. Communication patterns, temporal assumptions, consistency boundaries. Those are almost never the first things teams write down. The AI optimized within the rules it could see and violated the ones that weren't written anywhere.
So even the most disciplined teams have a blind spot if their rules only capture what they thought to formalize.
There's one more case I want to share, and it has a certain irony to it. The AI made the test suite better by every measurable standard, while making the system more fragile. The team had a microservices set up with consumer-driven contract tests. The consuming service publishes what it expects, and the producing service has to satisfy that spec before anything ships. Unglamorous infrastructure, but one of the best tools for catching silent drift, where two services gradually evolve out of sync. The AI was asked to clean up and speed up the test suite. It noticed the contract tests were slow, required standing up a test broker, and had a lot of ceremony. So it replaced them with mocked unit tests that verified the same behaviors locally. Faster, simpler, no external dependencies. By every metric you'd normally track, the numbers improved. What disappeared was the contract enforcement. The mocks now encoded what the team believed the API looked like on the day of the refactor. 6 months later, a developer added a required field to the producing service. There was nothing in the pipeline to say, the consumer doesn't know about this yet. The services drifted, the mocks stayed frozen, and the failure showed up in production. What I keep coming back to, the AI didn't do anything wrong by local reasoning. Mocks are a legitimate testing strategy. They genuinely are faster, and the individual tests were correct. What it couldn't know was that the slowness and ceremony of the contract tests wasn't a bug. It was the cost of the guarantee. Sometimes friction in a system is load-bearing, and recognizing that requires understanding why something was built a certain way.
That one really lands. The friction was the feature?
That's the exact phrase I'd use. And it generalizes. A lot of what AI tools interpret as inefficiency or unnecessary complexity was put there deliberately, often after something went wrong the first time. The context for those decisions almost never travels with the code.
So what do you actually tell developers? If someone's listening and they're using AI tools to refactor their code base, which most teams are now, what do they do differently starting tomorrow?
A few things that are practical and immediate. First, write down your architectural invariants, the things about your system that must remain true regardless of how the code changes, the boundaries that can't move, the dependencies that have to flow in one direction, the contracts between services. Make them explicit. Put them somewhere I can read them. That alone changes what I can do for you. Second, change what done means for an AI-assisted change. Done isn't green tests and a merged PR. Done includes a lightweight architectural sense check. Did anything move that shouldn't have? Some teams put that as a literal checkbox in their PR template. It sounds small, but it changes the conversation. Third, invest in fitness functions and be honest about their limits. They're great for the rules you've codified. They won't catch the tacit rules you haven't. Treat a fitness function gap as a prompt to write down something you've been carrying in your head. And the cultural one, which is harder, make skepticism a feature, not friction. The team that celebrates, wait, why is this module importing from there now, is the team that catches drift early. The team that treats that question as slowing things down is the team that does archaeology 6 months later.
The architecture has to become a first-class artifact, not just something that lives in people's heads.
Exactly. Think of your architectural intent as a contract with your future self and your future AI tools. The more of it you've made explicit, documented, encoded in rules, visible in the structure of the repo, the more AI can actually work with that intent rather than accidentally against it. AI is going to keep getting faster and more capable. The teams that get the most out of that aren't the ones who review less. They're the ones who've made their architecture legible enough that the right guardrails are already in place.
That's a great place to land. Make the architecture legible enough for the humans and for the AI. Claudine, this has been a really sharp conversation. Lots to think about for anyone who's been saying yes to AI refactoring suggestions without quite knowing what to ask.
Thanks, Bill. It's a topic worth taking seriously. I hope some of the specifics today gave people concrete things to look for, not just a vague sense that they should be more careful.
For everyone listening, slow down on the big diffs. Keep an eye on what moves rather than just what changes. And maybe write down the rules you've been carrying in your head for years. It'll help your team, and honestly, it'll help your AI tools too. Thanks for joining us, and we'll see you next time. This show is part of the VoxCrea system. If you want to show up like this without creating content yourself, go to voxcrea.ai and request a sample episode. See you next time.
I'll be here, probably refactoring something.